In this problem, it says two sides of a triangle have lengths of 6 and 10. The area is 18. Determine the smallest possible exact length of the third side. And so the method that I'm going to be using is what's called Hero's formula. And so the area of a triangle is the square root of the semi-perimeter times the semi-perimeter minus one side times the semi-perimeter minus the second side times the semi-perimeter minus the third side. Now the way you calculate the semi-perimeter is you add up the three sides and divide by 2. Now we only know 2 of them, so that means what we have to do is we have to leave the third in terms of, this in terms of c. So that's going to be 16 plus c divided by 2. So that's 8 plus 1/2 c. So let's see what we can substitute. We know the area is 18. So the square root of the semi-perimeter, which was 8 plus 1/2 c, s minus a, so that's going to be, we're going to subtract 6. So 8 plus 1/2 c minus 6. Then it's going to be the semi-perimeter minus 10. So 8 plus 1/2 c minus 10. And then finally, the semi-perimeter, 8 plus 1/2 c minus c. All right, so when we simplify this, we get 8 plus 1/2 c, 2 plus 1/2 c, negative 2 plus 1/2 c, and then 8 minus 1/2 c. So c is what we're trying to solve for, which is that third side. So first we're going to square both sides, get rid of that radical. So that's 324 equals 8 plus 1/2 c, 2 plus 1/2 c, negative 2 plus 1/2 c, and 8 minus 1/2 c. Now the next thing is, those fractions are kind of annoying, so what I'm going to do is I'm going to multiply this by 2, multiply that by 2, multiply this by 2, multiply that by 2. So the cumulative effect is multiplying by 2 4 times. Now in order to keep this as an equation, I have to do the same thing over here. I have to multiply by 2 4 times. So over here, 324 times 2 to the 4th is 5,184. When I multiply these by 2, this becomes 16 plus c, 4 plus c, negative 4 plus c, and 16 minus c. Now, what I'm going to do is I'm going to multiply these two together first, because these are conjugates. So when we multiply them, this is going to be a difference of squares. So we're going to get c squared minus 16. Same thing over here. If I multiply these two, I'm going to get 256 minus c squared. So when we expand this out, we're going to have a 4th degree polynomial. So that's going to be 256c squared. We multiply these two, we get negative 4,096. Here we multiply these two, so plus 16c squared, and then finally the last ones, we're going to get minus c to the 4th. And this is still all equal to 5,184. So let's rearrange this. This is going to be minus c to the 4th. We can combine these two like terms. So that's plus 272 c squared minus 4,096. So now we're going to subtract 5,184 over to the other side. So when we do that, it's equal to 0. Negative c to the 4th plus 272c squared minus 9,280. And I'm going to switch the negatives to positives just to make this a little bit easier. Minus 272 c squared plus 9280. Now this is a fourth degree, but it looks very much like a quadratic. So I'm going to first solve the underlying quadratic. So I'm going to replace it with y squared minus 272y plus 9280. And so the easiest way to do this is with the quadratic formula. So negative b, so 272 plus or minus the square root of negative 272 squared minus 4 times a times c all over 2a. Okay, so take negative 272 and square it. Into that minus 4 times 9,280. So we get 272 plus or minus the square root of 36,864 all over 2. We'll see if this, we can take the square root of that. 36864. Yes, we can. We get 272 plus or minus 192 over 2. All right, so if I take that and bring that up here, that means I either have 272 plus 192 over 2, in which case we end up with 232, or we have 272 minus 192 over 2, in which case we have 40. Now remember that these are equal to y, and y is just a stand-in for c squared. So 232 c squared equals 40. Now what we want is we want the smallest possible length for the third side. So that means that in order for c to be the smallest, that's not going to be it. For us, it's going to be the square root of 40. But we need to simplify that just a little bit. So we can't take the square root of 40, but 40 breaks down into 4 times 10, and we can take the square root of 4. So that means the smallest possible value that works is 2 square root of 10. And there's our answer, and we're done.